Thank you to everyone for joining us at The Telegraph and for staying with us that late. So my name is Herve. I work here at The Telegraph as a data scientist. I don't want to give you a long intro about what we're doing because you're guessing it, but yeah, we have an internal team of today 7 data scientists. We do a lot of work with the business in all of the different areas of the business. So as you can imagine, we also do natural language processing. As a newspaper, we have a lot of text data, and that's one of the area where we first started to use TensorFlow. But today, I want to talk about a slightly different topic. I want to talk about recommender systems. We will see, and I will try at the end of the presentation to touch some of the aspects of where TensorFlow is helping us on that project as well. Yeah, let's start. So why a talk about recommender systems? Well, one of them, well, they are everywhere. I mean, today, whenever you're going on the internet, when you go on the internet for leisure and you want to consume a TV program, you go on Netflix, basically recommender systems are used in the background to choose and try to influence what you will watch. When you go shopping, you go on Amazon, once again, recommendations are there to try to bring you where Amazon wants you to go. Come on the Telegraph, we also have recommendations, so really everywhere. And these are the obvious ones, but there are plenty of recommender systems which are kind of hidden and people, struggle to identify them. Think about jobs. If I go to LinkedIn, a recommender system will try to push me to another company. Dating, everywhere recommender system. So I thought that was an interesting topic to cover. And as well, as a data scientist working on the Telegraph, we are building a recommender system, so we start to develop experience in that field. So, well, the two obvious one, but what is impressive here is the scale of it. So 75% of what people are watching on Netflix is the result of people following a recommendation. 75%. On Amazon, it's 35%. It doesn't look big, but thinking about it, usually when I go on Amazon, it means that I have, something in mind, and I go there to buy something that I've decided to buy before I go on the site. But still, Amazon, is managing to grab my attention, and 35% of the transaction generated on Amazon are derived from recommendations. Those numbers are actually quite old, so it's 2013. Well, it is coming from a 2013 paper, so it might be that today, it's even we are even higher than that. Well, now, so recommenders everywhere. You've heard of the risk and you've read of the risk. And, as in the previous talk, so everyone you're talking about something happening in the world of technology, and people, and the media, the press is pretty good at, resurfacing all of the problem which might be coming with those recommendations. And now when we talk about recommender systems, and especially for us as a publisher, as a news organization, people are worried about the problem of the echo chamber and the filter bubble. So that idea that I have, my opinions, and the role of a news organization should be to enlarge my views and to try to bring me, contrast and show me that, articles and stories that would help me, to challenge my personal opinions. So now what people are worried about is, the fact that if more and more, as we've seen the numbers earlier, of what I'm consuming on the internet is coming from the influence of recommender system, so basically it's only reinforcing my opinion. And well, there is an interesting reflection here, obviously, to have, but I think we have to keep, and especially for us as a publisher, so we are using recommender systems, and we try to optimize the traffic on our websites by using those tools. But now, obviously, a big part is also, given to human being and the role of the editor. And so it's a matter of balance. And I think those discussions, have to happen, and especially in organizations like ours. So there is potential for a risk, but I mean, we also have, the tools and the responsibility and the responsible people who are there, which are supposed to help with that. I think we are sharing a slide here. Maybe when we talk about recommender system, well, we've been talking today about TensorFlow. So TensorFlow is mainly used to work on deep learning problems. We can do more with TensorFlow, obviously, because that's a framework in which we can do all sorts of computations. But deep learning made TensorFlow popular. So now deep learning is a part of machine learning, which is also a part of AI. My approach on that slide was slightly different from the one before, because when we talk about recommender system, people don't know exactly where it's fitting, and people, I've heard all of those terms. They've heard about artificial intelligence. They've heard about machine learning. They've heard about deep learning. Sometimes they're a little bit scared about, some of the problems we've been talking about earlier. But actually, the message here is some of those elements are quite old. And for example, when you come to AI, we haven't waited, until what happened over the last years and, the very push that is today happening in deep learning to start working with AI. So in the 1970s, people were building expert systems, and already some of the questions about AI was there, different level, different problems, but AI is not something new. Then you go into machine learning, same stories. So the idea of computer learning from data, 1959, it starts, to be something, and I think the first mention of machine learning is 1959. Logistic regression, which is still, one of the core elements of all of the machine learning, and what we discussed earlier, what we've seen, the basic element of a neural network. So at the core, the simplest form of a neural network is basically a logistic regression element. So those elements are coming from the 1950s. And then the deep learning, which is really the one which today, is bringing us, we've seen, the power of deep learning and the image recognition and stuff. But once again, artificial neural networks started to be developed in the 1940s. So, it took quite a while to come where we are. And obviously today, with the combination of many elements, but mainly the processing power that we have, some of the tools we have, like the framework we've seen earlier, mean that today we really have the possibility to build deeper and more complex neural nets. And the power of those neural nets has nothing to compare with what we had in those early age. And actually for AI, people are talking about the AI winter, which is a period of time where not much happened. Because in the 1940s, many of those ideas were, the math behind all of those models we're talking about today was already available, and it was there. Because the processing power was missing, people, stopped the research, and the industries were not interested into that because it was kind of, crazy people in the labs thinking about developing AI, but actually it was not possible to take that out of the lab and scale it and make it available for developers like us. And it's then probably in the 80s with Jeff Hinton's work on the backpropagation algorithm, which allow us today to train very, very complex deep learning models. That work, and also, as already said, explosion of processing power. So it's only, since that period that we had a revival of deep learning. And today, the world where everyone is going crazy about deep learning, maybe, sometimes in some extremes, because, all of those building blocks, machine learning is more than purely deep learning, and AI is more than that. And we tend to forget, all of the learning of the past and only focusing on the new stuffs. So we are lucky here tonight because we are talking about recommender systems. And recommender systems are actually, using elements from all of those layers. And it's not because I cannot draw properly that it's even going outside of the AI circle. But I think for us, that's important. And also, when we were having that little discussion about all of those phenomenon of filter bubbles. So here, when we do recommender system, at the Telegraph, we also have a place for human-created recommendation. So our editors are part of the equation. So, the first level of recommendation is a human being decided about what is important to inform the public. So that's one element which is not even, machine-driven. And then we've been experimenting with everything. So we have recommender systems which are kind of rule-based systems. So that would be, the old-school AI. We have a lot of machine learning, obviously, traditional machine learning. And today we are playing more and more with deep learning. So more details about the approaches that we are using and, basically what's available in the field of content recommendation. There are two big families of recommender systems. There are three columns on my slide, but I will explain. So the two families are collaborative filtering and content-based recommendations. Collaborative filtering is the idea where you learn the preferences of a user by analyzing the interaction or the ratings a user had on different elements of content. And then basically, users which have been giving the same ratings on similar content, you assume that they have the same preferences. And in terms of building recommendations, what you will start to do is you will find, so in my example here, user 1 liked story 1 and story 2. User 2 liked story 1 and story 2 as well. And we know that user 1 read story 4. So what we will do is recommend story 4 for user 2. And you start building those big matrices, and you manage to hence build your recommendations. And the kind of recommendations you're getting by those systems are the typical people like you also bought. So you will find that on Amazon and many commercial websites. Content-based recommendation, it's a very different approach. So there you analyze the meaning of your content. So something, quite specific to the world of journalism, where we have a lot of text and a lot of content. So basically what we're doing here is we use natural language processing to automatically extract the meaning from each of the articles we publish on the site. And when we try to do a content-based recommendation, we try to retrieve an article which has a meaning closely related to the meaning of the article you are currently reading. I'm showing you here an example of the New York Times website, where they have an article about Weinstein and cinema, and basically you see recommendations on content which are related in terms of the meaning. The third one I'm showing you it's a form of collaborative filtering, but it's something we are trying to apply here. It's slightly different to the pure collaborative filtering, because here what we're doing in terms of learning the preferences of the users, we count the consumption a user is having of different categories and different type of contents. So in the example here of Netflix, it would be you count how many movies the user has been viewing in action and adventure, in thrillers and different categories. And based on that, you start to draw a profile about the users. So you're learning the preferences of the users by simply counting how many films in each of the categories the user has been watching. And then based on that, you can infer content of interest. So that's also something that we are applying here. Now the big question is, okay, you know how to do recommendation based on collaborative filtering, you know how to do recommendation on our content, so why so many recommenders, and why do we need more than one, actually? Well, as we've seen earlier, they all work very differently, and they will be promoting very, very different behaviors. And also, they wouldn't work in the same situation. So if I come back in the world of newspaper, we've seen that we have content-based recommendations. And I told you that content-based recommendation is giving me recommendations for articles which are pretty similar to the one I'm currently reading. So if I take a simple example, if I'm reading a story about Trump and the problem at the Mexican border, NLP will be pretty good at retrieving other articles talking exactly about the same topic. So you will recommend me a first article, well, that's okay. A second one, I'm bored. A third one, I stop reading. And pretty quickly I'm saturated because all of those articles are so similar that I don't want to read 10 of them. So that's where you introduce other form of recommendations. And for example, collaborative filtering is bringing a lot of surprise. So we call that serendipity to the recommendations, because it's no longer based on the piece of content only, but it's also based on the interaction other people had with the piece of content. So it's kind of, yes, people who were interested in that article went somewhere else, and that somewhere else might be quite surprising for me. So that element of surprise is actually quite interesting to exploit in some instances. But now when we think about what you're doing and what is your objective as an organization, you can have a strategy about that. So for example, when I have a mid-article recommendation, so I start reading a first paragraph, second paragraph, and then I have a link in the middle, an insertion in the middle of that article. I want that kind of recommendation to be for a story which is closely related to the one I'm reading. You don't want to interrupt my flow and distract me with something too surprising. So on that kind of recommendation, you go rather for something quite narrow. Now, when you have a box on the website, let's say on the on the rail on the right of the website, as we have on our newspaper, there you have more space for surprise, and yes, you want to try to attract my attention, but it might be a topic I'm not even thinking about. I'm currently reading a story about politics, and you will try to bring me to entertainment, or something that might be difficult for me to quite immediately understand, but could be of interest to me. And so once again, the right combination of recommender will depend on the type of content. Am I reading a story about sports where we have some specific constraints? So, for example, if I'm currently watching the Football World Cup, and you start recommending me stories which are serving the results of the past World Cup, well, that might be something I'm not interested in. If I'm reading a piece of content which is more evergreen, as we call them, so let's say if I'm reading a piece of content about gardening, and you're serving me a story about a recommendation on what to plant at this time of the year, which has been written 2 years ago, that content might still be quite relevant for me today. Then the user journey. When you are on the page, I already know some information about you. You could be an anonymous user, but still you have a cookie, and I know if it's your first visit or if you are a regular reader. So if you are on a first visit, I don't know many things about you, and maybe my strategy could be to serve you a list of the most popular articles at the moment on the site. If you are someone coming regularly on the site, we know that that approach wouldn't work because there is a high probability that you have already read that stories. So once again, a combination of content, journey, and objectives should tell you what recommender to use. Now, an interesting topic, and not so many people are talking about it, because when it comes to the question on how to evaluate how good the recommender system I built is, people tend to stick to the click-through rate metrics. So I'm showing you a recommendation. Are people clicking on the recommendation? Yes, no. Well, that's a way to evaluate the accuracy of the recommender, but actually there is more than that. And we know that there are tricks to inflate accuracy. So I could attract you with light topics, celebrities, and there are a list of topics which I could use to artificially attract you and inflate my CTR. But it's not necessarily something that I want to do as a brand like ours. you don't want to compromise on the quality of what you are serving for that purpose. So then all of those other metrics are coming into play, and you can start, based on your objective, to decide for which one you want to optimize. For example, newspaper novelty could be a new one. Do I want, to serve stories which have not been written by many people? So that would be, trying to surface those. Coverage. Are there corners of my site where I have less traffic, and am I promoting for that? Diversity, ensuring that if I'm coming to the site on a regular basis, I'm not receiving the same recommendation regularly. So plenty of elements we can play with there. Now, coming back slightly to what we discussed earlier and talking about one of the elements that we have behind the recommendation system, I wanted, to bring it back to the topic of tonight, which is TensorFlow and machine learning, TensorFlow and deep learning. So to do so, I won't lie to you. We are not currently working in production or advanced development on any recommender which are relying, which have an algorithm which is coded in TensorFlow or something like that. There are more and more articles which are published, and there is a lot of research happening currently, and we are reviewing, the proceedings of some academic conferences, and people are getting interested in trying to replicate similar approaches to collaborative filtering by using deep learning. So we are just touching on that, but actually there is one element where we definitely need deep learning. It's to extract meaning from the text. So we've been talking about content-based recommendation, and we've been talking about user preferences, so the user profile kind of recommender. And on those two topics, we are actually using a lot of we start to use a lot of TensorFlow. So one of the problems we have with our content, until now, a journalist was writing an article, and we were giving them the opportunity to freely give tags to the article written. And obviously, those people know how to write, they are very creative, and they tend to generate new tags every time they're writing a piece of content. And we did an analysis a couple of years ago, I think, or a year ago, and we followed the stories written around Pokemon Go. So at that time, we had dozens of articles tagged with Pokemon Go. And then we started to have a reflection about how useful is that? Because if I want to link that to video games from the past or from today, well, Pokemon Go is not helping me at all. And there are plenty of elements like that where the tags, are spiking over a short period of time, and then they're no longer used. And what we're trying here to do is basically to retrieve relevant content for our users. So what we're trying to do today is to first of all, we want to build a curated list of topics that we can build in a way where persistence over time is we can guarantee that they will be there for a long period of time. So by organizing all of the tags in a hierarchy, so for example, if instead of using Pokemon Go, I'm using video game or maybe mobile games, I come at a level in the hierarchy where I'm sure that even if Pokemon Go is no longer used in 2 years, video games will still be there, or mobile games will still be there. So we came with that list of themes or topic which should ensure persistence over time, and then basically we're using machine learning to automatically annotate the articles. And that piece of information is an extra element that we have, an extra piece of information that we have about each of our articles. So how we do that? So today we have that list of 108 topics, and as an input we have our raw articles. So as discussed earlier, by Lawrence, what you need to do first is to extract features from your text. So here we are relying on an algorithm. We're relying on word embeddings, and one of the most famous algorithms to extract word embeddings from text is actually word2vec, which has been developed as the PhD research of one of your colleagues at Google. And so what we're doing here, basically, what are the embeddings? So there are different ways of extracting meaning from an article. So the traditional way were used on frequencies of words in the article. So you take the vocabulary, a list of, say, 10,000 words, and you build a vector for each article, which is counting the frequency of each of the 10,000 words. So a lot of the traditional NLP was based on that principle of counting the frequency of words. Now the new idea with word embeddings and word2vec algorithm is actually to extract another set of features and to basically extract. It's an exercise where you try to position all of the words in a space, and the distance between two words in that space will be based on the meaning that the words has. So the algorithm will consume a lot of text, and it will start to analyze how words are relatively positioned, and based on that, it will place them in the space. And you end up with a vector for each of the words of the language, which has some information about the meaning of the word. So actually, the embeddings for man and king will have the same relative distance as the embedding of woman and queen. And because of those relationships, you have a pretty good extraction of the meaning for each of the words. And then one of the other beauty of that model is that you can go on the internet and find the weights for different pre-existing embeddings. So what we're doing here in that model that we are currently using is the first layer. So we have an input layer which is ingesting my documents, and then we feed that into an embedding layer. And actually, we're not training that embedding layer, but we are using a pre-trained embedding layer, which has actually been trained on a massive corpus, which is something that only companies like Google or Facebook can have access to. Even us, with our newspaper, we don't have enough annotated content to build that. So we use that as the entry into our classification model, and then we go with a set of convolutional neural networks all the way to the output of the model, which is making the prediction about the probability of a text to have a certain topic. So so that's what I wanted to say today about our use of one of the use of TensorFlow we're doing here. Actually, the output, some of you might notice, it's Keras on the top of TensorFlow. So that's a description of the model in Keras. As discussed earlier, Keras is an abstraction layer on the top of TensorFlow, which is allowing you to more concisely define a model in TensorFlow. But basically, that's what I wanted to tell you today. So show you different techniques, different approaches to building recommendations. Show you some elements of the work we're doing on recommendations, on which we are relying on TensorFlow, and that's it. So if you have any questions, do not hesitate to come to me.